Geofabrics Australasia proudly presents a series of videos that relate to the Australian standards that are used in testing of geosynthetic products and how these tests relate to practical field applications. The standard environment for this test method is an ambient temperature of 20 degrees Celsius, plus or minus 2 degrees Celsius, and humidity of 65%, plus or minus 3%. 10 trapezoidal specimens per sample direction are required. The testing area dimensions of each specimen will have the long side edge of 100 mm by the short side edge of 25 mm, with a distance of 75 mm between. A cut of 15 mm perpendicular to the middle of the short side edge is also cut. On either side, there must be enough specimen to be clamped in the jaws. The specimens are sampled so that they are widely spaced as possible over the whole surface of the sample, so that their positions are symmetrically different in the longitudinal and cross directions. 100 mm from either edge. Any visually non-representative, soiled or damaged part of the sample is discarded. Jaws are set up on a tensile machine with a 25 mm gauge length. The two jaws measure 50 mm by 75 mm, with the longer dimension perpendicular to the direction of application of force. The specimen is drawn on using a template to mark the top and bottom edges of the jaws. The specimen is inserted between the jaws, lining up the top edge line with the bottom of the top jaws and the bottom edge line with the top of the bottom jaws, taking care to make sure that there isn't any hangover on the vertical sides of the jaws. The test is started and the jaws will move apart from each other at an extension rate of 300 mm per minute until the sample ruptures. The maximum tearing strength is recorded to the nearest 10 newtons. The 10 specimens per direction are averaged to get an end typical result for that sample. The mean, standard deviation and coefficient of variation are reported. The two directions are reported separately and the 5th and 95th percentiles may be reported. Relation to the field. This is a performance test, as it attempts to mimic potential failure under loading of a damaged geotextile. Geotextiles can be damaged during installation where rocks are dropped onto a geotextile, for example in revetment or drainage blanket applications. A tear in the geotextile can propagate from a point of damage when it is subjected to tension.